Assalamualaikum, my name is NurNajihah binti Amran and my metric number is AA181852. So today, me and my friends will present our research project about synthesis of green zinc oxide nanoparticles using Cymbopogon Nardus extracts as escaping agent for treatment of petroleum refinery wastewater. Now, I will explain briefly the introduction about this research. In introduction here, we have research background, problem statement, objective of the study, scope of the study, and the significance of the study. First is research background. As we know, petroleum refinery wastewater is notable for its high substance of poisonous toxins, which are not harmful and dangerous to human and the environment. In addition, petroleum industry keep expanding, which can cause the increasing of pollution to our environment. Of course, there is a few methods to treat the petroleum refinery wastewater such as adsorption and coagulation, but not all of the method is effective to treat the wastewater due to its high contaminants. So we use photocatalytic degradation because photocatalysis has been proven to be an effective technique to degrade phenolic wastewater by use semiconductor or as photocatalyst. For the photocatalyst, we use zinc oxide. Zinc oxide is an ideal photocatalyst because a low-cost production and is insoluble in water. But synthesis of zinc oxide nanomaterials also has its downsides, such as the production of harmful and toxic byproducts, the use of toxic reagents, and the use of expensive instruments. To overcome this problem, we use green plant as a capping agent for the synthesis of green zinc oxide nanoparticles. Next is our problem statement. Our problem statement are petroleum refinery wastewater is well known for its high content of persistent organic pollutants, POPs, that may not completely remove during treatment process. Heterogeneous photocatalysis using zinc oxide nanoparticles has been vastly studied and confirmed to have the potential to completely degrade POPs in petroleum refinery wastewater. However, the use of green zinc oxide nanoparticles using selected plant in photocatalysis degradation of POPs in petroleum refinery wastewater is yet to be studied. We have three objectives and each objective has its own scope of study. So, objective number 1 is synthesis of zinc oxide Cymbopogon Nardus nanoparticles. The scope of study is the Cymbopogon Nardus leaf is extracted using conventional heating with water as a solvent due to its simpler route at moderate temperature, which is 80 degrees Celsius, and zinc oxide nanoparticles is synthesized via precipitation method under different ratio of zinc oxide solution and Cymbopogon Nardus leaf extract. Objective number 2 is characterization of zinc oxide nanoparticles with scope of study. The ZNOCN nanoparticles is characterized in terms of surface morphology using field emission scanning electron microscopy, equipped with energy dispersion spectrometry. And the ZNOCN nanoparticles is characterized for functional group using Fourier transform infrared spectrometry. Objective number 3 is evaluation of performance of ZNOCN for petroleum refinery wastewater treatment. The scope is treatment of petroleum refinery as effluent in the presence of ZNOCN nanoparticles, and the treated petroleum refinery wastewater will be analyzed after photocatalysis process in terms of the color intensity, turbidity, pH, and chemical oxygen demand. Last introduction for this research project is significance of the study. We have 4 points here. First, synthesis of zinc oxide nanoparticles using Cymbopogon Nardus leaf is fairly new field of research which able to reduce the amount of waste going to the landfill. Second, the biological compound present in the Cymbopogon Nardus leaf responsible as a capping agent to reduce the particle size and minimizing the agglomeration of zinc oxide nanoparticles. Third, in Malaysia, Cymbopogon Nardus is easily grown and is widely used in industry of perfumery and aromatherapy. And fourth is the utilization of plant as a substitution of chemical feedstock to synthesis metal oxide nanoparticles with high quality might be contributed to the economic benefit at a commercial scale. That's all for the introduction.
Hi, my name is Amin with the metric number of AA181926, and for the next part, I'm going through with our literature review. There are two sections in our literature review. The first one is petroleum refinery wastewater, or PRW in short, and the second one is about photocatalysis. So first, let's take a look with petroleum refinery wastewater. PRW generated around 0.4 to 1.6 times the amount of oil processed, and refining a barrel of oil requires around 65 to 90 gallons of water, which is equivalent to 247 to 340 liters, which is a lot. Therefore, PRW need to be treated before it can be safely removed to the environment. So what is in PRW? PRW consists of mostly persistent organic pollutants, or POPs, that are dangerous to living organisms. Most of POPs are aromatic compounds which are relatively water-soluble, therefore can react and produce more harmful chemicals or compounds. These are the parameters that are need to be looked out for in PRW. Chemical oxygen demand, biochemical oxygen demand, total suspended solid, total organic carbon, color, ammonia, turbidity, sulfide, phenol, phosphorus, oil and grease, and pH. The treatment process of PRW consists of three major processes, which are physical processes, chemical processes, and biological processes. All of these processes have three treatment, which is primary treatment, secondary treatment, and tertiary treatments. These are the most common technique used in treating PRW. However, we are going to focus on photocatalytic degradation, as it is more cost-effective and faster reaction rates. So on to the second section, photocatalysis. What exactly is photocatalysis? By definition, photocatalysis is a process which accelerates photoreaction in the presence of catalyst. In our case, the catalyst being semiconductor. The efficiency of photocatalytic activity depends on several factors, which are concentration, pH solution, temperature, semiconductor loading and structure, inorganic species presence, light intensity and wavelength, and the ability of the catalyst to produce electron-hole pairs. In wastewater treatment, the most commonly used catalyst is titanium dioxide. Titanium dioxide is quite expensive. A viable alternative to this being zinc oxide. Both titanium dioxide and zinc oxide have the same band gap size, which is 3 electron volts. So what exactly does zinc oxide brings? Zinc oxide has higher photocatalytic performance, larger absorption efficiency, non-toxic, and are more widely available compared to titanium dioxide. Zinc oxide nanoparticles morphology can be divided into 4 groups. The first one is 0 dimension, second one is 1 dimension, the third one is 2 dimension, and the fourth one is 3 dimensions. To synthesize zinc oxide nanoparticle, we can use the conventional method, which has 2 approaches, solution-based and vapor-based. Or we can use green synthesis. Green synthesis can avoid drawbacks such as expensive expenses and the use of hazardous chemicals. Green synthesis is basically using plant part extract, as they are rich in phytochemicals, which can act as both capping and reducing agent. Here are some examples where leaves from multiple plants are extracted to degrade multiple dyes. And here are the examples from fruit peels and flowers. For our project, we are going to use Cymbopogon Nardus, or commonly called serai wangi in Malaysia. Cymbopogon Nardus come from the Poaceae family and has multiple purposes, from cosmetic to culinary. In Malaysia, for example, it is being used as an essential oil. The mineral content of this plant are zinc, sodium, calcium, iron, phosphorus, potassium, and magnesium. Cymbopogon Nardus does show potential to be used in wastewater treatment. However, there is not yet enough study on the subject.
Assalamualaikum warahmatullahi wabarakatuh. I am Nur Ain Maisarah Bahrim and I would be presenting the methodology. Our methodology consists of 3 parts with each part corresponding to this study's objectives. The first phase involved the extraction of phenolic compounds of Cymbopogon Nardus, CN leaves, and the synthesis of zinc oxide with Cymbopogon Nardus, ZnOCN. These are the steps involved in preparing plant extract. First, the collected CN leaves are washed several times with tap water. The leaves are dried for 7 days under direct sun before being crushed using a grinder and sieve to give particle size in a range of 0.4 until 1 mm. The extraction of phenolic compound from CN is carried out using convectional heating process. The leaves powder is weighed and mixed with the ionized water at a water to powder ratio of 1:5. The mixture is boiled at 80 degrees Celsius for 60 minutes until the color of the solution changes into brownish. The extract sample is filtered. The extract is collected and stored at 4 degrees Celsius and ready to be used for the synthesis of nanoparticles. ZnOCN nanoparticles is then synthesized using precipitation method. 0.15 mole of oxalic acid dehydrate solution is added slowly into 0.1 mole solution of zinc acetate dehydrate. CN leaves extract added into 10 ml of prepared ZnO mixture at the ratio of 3:1, 5:1, and 9:1. Stirred for 12 hours. The precipitate obtained is filtered and consequently dried in oven below 100 degrees Celsius for 1 hour. The precipitate is calcined in the furnace at 550 degrees Celsius for 2 hours. The white powder of ZnOCN is formed and kept in a sealed container. We will also be using commercial zinc oxide for comparative purpose. Moving on to the second phase, involving the characterization of synthesized ZnOCN. For its crystalline structure, ZnOCN will be characterized using X-ray diffraction or XRD. The surface morphology of nanoparticles will be examined using field emission scanning electron microscopy (FESEM) equipped with an energy dispersive X-ray analysis (EDS). The characterization for functional group of ZnOCN were performed by Fourier transform infrared spectrophotometer (FTIR) under wavelength range of 400 until 4000 per centimeter. Lastly, the third phase consists of petroleum refinery wastewater (PRW) treatment and the analysis on the treated wastewater. For wastewater treatment, we will be using a photocatalytic reactor where ultraviolet UV lamp is used to activate the photocatalyst. Shown is the schematic diagram for the reactor. The sample of treated wastewater is analyzed in terms of color intensity using DR6000 UVV spectrophotometer. Meanwhile, both untreated and treated wastewater are analyzed for their pH using benchtop pH meter, turbidity with turbidity meter, and chemical oxygen demand COD using DR6000 UVV spectrophotometer. These water quality parameters are analyzed according to the standard method for examination of water and wastewater as indicated.
Lastly, I will show you our expected results for this project. As you know, we will treat petroleum refinery wastewater by synthesis the green zinc oxide nanoparticle escaping agent. We use Cymbopogon Nardus extract as green plant, which also known as citronella grass. Our first expected results is we may generate zinc oxide Cymbopogon Nardus nanoparticles and determine the optimum ratio of Cymbopogon Nardus leaf extracts to zinc oxide. Secondly, from the analysis, we could determine the size structure of the ZnOCn nanoparticles and expected to obtain small size and uniform nanoparticles in the range of 25 until 200 nanometer. Finally, we expect the petroleum refinery wastewater could be treated using photocatalytic reactor and a high percentage elimination of more than 80% could be achieved for each parameters of water qualities analyzed. That is our expected result. That's all from us. Thank you for watching.